Hello everyone. In this video, I'm going to show you how to run these Lego EV3 robots, the ones that if you were in a robotics program, you probably have seen and work with them. And these are really good for just beginners to just touch a fill of sensors, actuators, and working with a differential drive robot. So they might be good. So, and you can make them in all different sorts of robots. So here is a mobile robot. You can turn them into manipulators. You can turn them into kind of humanoid-like robots. So these are Legos. So you can do lots of different things with them. In this video, I'm going to show you how to control them from MATLAB. So if you want to do some automation project like the one I have on my channel, so here, if you go to the playlist and look under my projects, one of the projects that I showed you is this one, where my MATLAB class students, they basically ran Lego EV3s. One of them, they turned it into a conveyor, and you see here, this one, and the other one, they turned it into this manipulator. Okay, and it was sorting Lego parts based on their color. Everything here is controlled through a MATLAB application, you see here. And so it was controlled by a GUI, basically. And you also had webcam here and so on. So if you want to do automation projects like these with Lego or any other project, and you want to do it with MATLAB so you can use all other toolboxes in MATLAB, like, for example, capturing pictures or videos from these webcams, processing those, do computer vision, do machine learning, or anything like that, how can you possibly do that? So let me show you. So there are three ways that you can connect to a Lego EV3. The simplest one is with a USB cable. So here we have a USB cable, as you can see right here, and you can connect it down to the USB port. That's one way to connect. That's the simplest way. It doesn't need any extra arguments. So you just say command Lego EV3 USB and it connects. By the way, the support package for Lego EV3 is not installed by default. You have to install it. So you have to go here to Home, go to Add-ons, go to Get Hardware Support Package, and then find the support package for what? For Lego EV3. So you have it both for Simulink and for MATLAB. You find it, you need to have a account in MathWorks. Look here. So if you go down, you see here, MATLAB support package for Lego Mindstorm EV3. So once you download this and install this package, then you're going to have all these commands like Lego EV3. So you pass to it USB and it connects. So look here, if I run this command for you, look in my command window. So you see it created an object and it shows how it is connected. It shows the battery level and it shows that this guy has 4 sensors. Okay, you see connected sensors, right? So if I want, I can say my Lego dot and then what? Go to connected sensors and it shows what kind of sensors are available. Let's see. Here we go. You see, so I have a gyro sensor, I have a sonic sensor, ultrasonic, I have a touch sensor, and I have a color, and you should be able to see them as well here, right? So you see this one here is the touch sensor. This one on this corner, if I bring it closer to you, you see that's the gyroscope. This one down here is the ultrasonic, and this one here is my camera. So I have 4 sensors, and the sensors are going to go to the back of the robot and attach to ports 1 to 4. And the actuators of the robot, the motors, are going to go to the front of the robot and be attached to ports A to D. Here I only have 2 motors, big motors, connected to B and C, and those are used to drive the left and right tires. So they made this robot a differential drive robot. Okay? This robot has a screen which you can write whatever you want on it. It has these lights, it has the turn on and off button and a bunch of buttons here. and everything now can be controlled through MATLAB. So first here I connected via USB. You might say, what if I want to connect it with a Bluetooth or Wi-Fi, so I don't have limitations on this cable? Because here you see I have this big cable, a USB cable, and it limits how far this robot can go from the computer. But if you want this robot to be completely free and move remotely, then controlled remotely, one way is to pass Wi-Fi, and you need to find the IP address of the Lego and this ID here. So in order to connect that, you need one of these Wi-Fi dongles here. It's a Netgear. If I bring it very close, hopefully you can see. Maybe it's blurred, but it's a Netgear Wi-Fi dongle, okay? And you buy these, and you can attach them here to this USB port on this side, okay? By the way, these robots can also get SD cards if you want to record something. So here is a USB dongle, and you need to do some settings. I added these settings for you as comments here. The steps to connect with Wi-Fi. If you want to connect with Bluetooth, now you have a Bluetooth dongle, and that looks like this. So this is a Bluetooth dongle. The one I have is, the model of it is DG40SA. Okay, so it's Avon 3 Bluetooth modem, Bluetooth dongle, and you can connect this to the USB. Instead, now you can work with Bluetooth. So you can control it from your phone or your computer if your computer does have a Bluetooth. And the command is going to be Lego EV3 Bluetooth and then the COM port. And again, you need to do some steps. Again, these are added as comments for you. So I shared this file for you under video description, the link for it, so you can download and play with it. And everything here I got from MATLAB help documents. So none of this code is really mine. I got them, the sample codes from MATLAB help documents on Lego EV3 support package, and I'm trying to explain them to you. So here, for right now, I guess I'm good to go with USB. Now, let's see what kind of controls we have over this robot. The first thing is I can clean up the LCD screen. So the LCD screen, if you can see here, it has something written on it. You might not be able to see that very well, but what it's showing here is Hello EEA, okay? So if I want, I can clean it up. So I can call the command clear LCD and pass to it the robot object. And look, once you do that, you see, now there is nothing on the screen. The screen is all cleaned up. Okay, now if you want, you can show whatever you want. You can show some text to it, so you just pass it the text in a quotation mark, and then pass it the row and the column for the start location. So here I say go to row 2, column 3, and write in hello EEA. So you use the command write LCD. And if I do that, I don't know if you can see it or not, probably not very well, but right now, you can see that there is something written on it. If you zoom in, it should say hello EEA. Okay, so you can control LCD. Now, LCD is not really much of application in terms of the robot, right? So we want to do something more interesting. And you might say, what? Well, let's take a look. So, for instance, we can have the robot beep, so we can use the command beep and pass to it my Lego. It's gonna do a very small beep. Listen. You see, again. You see, it did a small beep. Might not be super loud, so if you want to play some loud tone, you can use the command play tone, pass to it the object, then the hertz, the frequency of the signal, the duration of the signal in seconds, and the volume level. So here I wanted to do a longer beep for me at 500 hertz, 3 seconds, level 20, volume level. Now listen, it's going to be really audible. There we go. Yeah, so you can do that. This light here that you see right now is off, but I can turn it on and make it red, yellow, or anything I want. So red is typically when there is something going on, so I can use the command write status light and pass to it red, yellow, or off. So look here, right now it was off. Now look, when I run this command, the LED light will go red. Look, you see? It turned red now, and I can turn it off by running the second line. Look, here, I turned it off. I can read if this up, down, left, and right buttons are pressed. Right now, this button is not pressed, so if I read the status of that by using the command read button, my Lego and up, the thing that it shows on the workspace is going to be 0 because it's not pressed. Look here. You see, answer logical 0. So 0 means what? 0 means 0 for not pressed and 1 for pressed. Okay, so now if I press it again, so if I keep it under press and I run the same command, look what happens. So I try to run this command, but I press this up button here. Okay, I press the up button and run the command. So press it. You see, now logical 1. And you can do the same thing for bottom, left, and right. So these were those commands about sound, light, and LCD, which might not be super interesting to you if you want to do robotics or automation projects. So let's get to the sensors and actuators. So there are 4 sensors, as I showed you earlier. There is a touch sensor, color sensor, ultrasonic, and gyro. And touch sensor here, you can create the object for it by passing the Lego object and the port that it is attached to. This is attached to port 4. So you create it and then you read the value of the touch sensor, which is again similar to those up, down, left, right button. It's 1 if it's pressed, it's 0 if it's not pressed, right? So here, let me show you. So here I create the object and read it. You see the read value is 0. Because it's not pressed. Now if I press it and run this single line of command again, so here I press on this button and I run it again, and you see it is now what? It is logical 1. Okay, so you might say, well, if you have those buttons already and these buttons can do all the 0 and 1 pressed or not pressed, what's the goal of having this touch sensor? Well, the touch sensor is used for when you want to avoid a collision with the objects, when you are going around the environment and you want this touch sensor to be the first thing hitting the wall or object and not your robot running into the wall. Then instead of having your touch sensor up like this, which I just put so I can easily press it, you take this touch sensor off. Look here, you take it off, and then what? You install it to the front of the robot like this. So now when this robot is driving forward, the first thing that would hit the wall is the touch sensor. So you say, hey, keep going, keep driving the motors while what? This read touch of my touch sensor is equal to 0, which means I haven't hit anything yet. And then what? Then stop. Okay, so that's typically these touch sensors are put on the front or back of the robot, or maybe sides, but mostly front and back of the robots. To what? To ensure that you can avoid collision with surrounding objects. Then we have the color sensor, the camera, which is here, this guy that you can see. And the color sensor, not only it can detect a few colors, it can also detect the intensity of the light. So let me show you. Here, you define the color sensor. You say it's attached to port 3 using the command color sensor, and then you use the command read color and pass this object to it, and it gives you a color. Now this color is not all of the colors, it's only 7 colors: black, blue, green, yellow, red, white, and brown. You cannot detect gray or orange with it. And if it's none of those colors, it returns a none. Now, one important thing you have to pay attention to is the camera has to be very close to the object it is looking at. So if I have this object even 2-3 centimeters off from the camera, it's not going to be able to detect the color properly. Let me show you with an example. So here I have this cap, right, of this marker, and it is green. And let's go ahead and see what color it can detect for us. Okay, do you see here? It detected black, although this is obviously green. Now I repeat the same command, but I move this guy very close, like this. I bring it very close to it. Now look. You see? Look here, green. So if you want to do a line following with this Lego EV3 robots, you need to make sure this camera is, first of all, is parallel to the surface, and then it is brought very, very close to the line that is on the floor. So you should not do it like I have right now. You have to take this off, and then what? You have to look here. Let me move this up a little bit. You have to bring it something like this, very, very close to the floor. Let me see if I can show you a better picture by moving this back. Here, you have to bring it very, very close to the floor. Otherwise, guess what? Your line following job is not going to be as beautiful as expected. The next sensor I have is a sonic sensor. By the way, Lego EV3s can come with IR sensors and they can come with temperature sensors too. Of course, most of these temperature and IRs, they're mostly belonging to the previous generation of these guys called NXT robots. But the EV3, as far as I know, it can also come with IR sensor. So the one I have right now, this is an ultrasonic. It's not an IR sensor. So that's this guy here. It's an ultrasonic sensor. It is attached to port 2, so I go ahead and create the object for it, and then what? I use the command read distance, which reads the distance for me in meters. Now, seems like I had some typo here, so that should be my Lego. That's what I called it. And again, it's attached to port 2. So here I'm going to put some object in front of it, and let's see if we can measure the distance. So I put this pack of stickers right in front of it, and now let's run this command. So measure the distance. You see the distance is 11 centimeters or 0.11, and that is relatively accurate. I mean, like, it's not super accurate. It's a little bit more than 11 centimeters, but it's not too bad. So, and here I'm going to repeat that. This time maybe I bring it closer. So if I repeat the same experiment, bring it closer, so we see if it's working. You see now the distance is 4.9 centimeters. So your ultrasonic is working, and again, you can use ultrasonic for controlling the distance that the robot can have with respect to any object in front of it. So it can be used for a collision avoidance, right? It can be used for following objects or any other thing. And finally, we have gyro, and gyro here in this case is attached to port 1. And gyro, as you know, it gives you the angle. One of the things that you might need to do with a gyro before using it is to reset the angle of it to 0. Because if you have used it previously, the angle that it reads, even though you have not moved the robot yet, it can give you a non-zero angle. Let's try that right now. Let's read the rotation angle with my gyro. The angle should be in degrees. See if it gives me 0 right now. Let's see. You see? Look at that number. 4164. That ain't 0. So you want to use this reset rotation, but remember, this reset rotation, it resets the angle, or let's talk about this. This rotation angle in degrees since the creation of the gyro object. So if you want really this reset to work properly, redefine the gyro and reset it first. So run all of them together and then measure the angle. You should be good. So let's go ahead and do that, see what we get. So I mark them F9 and hopefully we get 0 angle. There we go. You see, now my angle is measured at 0. There is another command that called read rotation rate, and that is supposed to give you angular velocities in degrees per second. I'm just warning you that it is not really reliable, okay? In general, this gyro sensor is not 100% reliable. It's not really a great gyro that is installed on Lego EV3. If you want, you can do odometry. Odometry is much better. I have a video on that. Based on the encoder values of these motors, which are more accurate, you can estimate, and the radius of the tire and this width of the chassis, you can measure the rotated angle much better than this gyro, to be honest. So here you see the robot is not turning, right? So if I run this rate command, it should give me 0, right? But look, it doesn't. You see? So this is not super reliable, just warning you. Finally, go to actuators. So actuators, Lego EV3 has 2 large motors that you should be able to see here, right? This is one large motor and the other one for left and right side. And it has a medium motor too, which I have not attached. The medium motor you can also attach to port A or D, and that is used for like moving something, like you can use like a gripper, right? You can create a gripper with that, or something that lift objects or grab objects. So here I did not bring that, but it's not really a major deal. All you need is to say to which port it is attached. Instead of calling it right or left motor, you can call it gripper motor, and then you can have it move. So here I use the command motor. I say motor B is my right motor, and then the command I use is the speed command. So I say right motor speed 50. So this is a percentage. It can go from 0 to what? This is a percentage of max RPM basically. So here I use it at 50% max RPM, and then in order to start it, I use the command start. Then it starts moving. If I want to read the angle of it using encoder, I use the command read rotation, and it tells me how much it has rotated in degrees. If you want, you can reset the rotation angle of it, and if you want, you can stop it, okay? So this is what reading the encoder, and it's going to be in degrees. And you can do anything similar and everything similar for the left side, which is attached to port C. So let me go ahead and define the right motor and define the speed of it. And here I'm going to run it for you. Now, of course, it's on the table, so I don't want it to do some crazy maneuvers. So you know what, let me change the speed to maybe 20%. And right motor start. Here we go. See? Okay, I stopped the motor using the command stop, and now I can read the rotation, right? And this is in degrees, so really, did it rotate 1900 degrees? Yes, I would say if you divide it by 360, it's about 5 full rotations, and definitely the right tire here has rotated more than 5 full rotations. Okay, so that is in degrees, and you can reset the rotation, as I said. So if you read it, it starts reading from 0 again, because this encoder value that it returns, it's since the creation of what? The creation of the motor object. So similar to encoder, if you want it to start from 0, you better reset it. And as I said, you can do the stop, and you can do everything that you did about the left motor, okay? And once you're done, you can clear the My Lego object or clear all, so none of those objects exist and they are freed basically. Okay, so this is an overall overview of running a Lego EV3 with all the sensors that it has. I mean, the ones that I have. You know that it does have an IR sensor and so on. And you can do all sorts of projects with it. So hopefully this video was useful to you and you learned how to use code. Let me put it this way so you can see this beautiful robot maybe a little bit better, right? And you might be able to do lots of different projects with this robot. You just need to run the proper commands. So I'm gonna share this file with you under video description, and feel free to use it and play with it. Thank you so much for your attention. I'll see you in the next video.